All right, I thought it would be kind of cool to have a, let's call it a Wednesday workout. What I do is I go into Lumen and I look to see what are some problems that are the most missed or any problems that your classmates sent me. Now, remember that I do have other videos already of these problems worked out, but I thought it would be kind of nice just to have a peek in. So if you haven't gotten started, then this might help you a little bit. All right, so this is in Module 0, Homework 2, Exponents and Scientific Notation. And I can see this is exponents because exponents is the number up in the air waving like it just don't care, right? See, you didn't know you could sing in math. And there's this kind of cool thing in with exponents that if your base is the same, and that's your exponent up in the air, if your bases are the same, and I don't know about you, but 12x and 12x are the same, there is a rule of exponents that says you can keep the same base and you can subtract the exponent. So I would have 12x, and I can put that in parentheses, doesn't really matter, but I can do that. And then 5 minus 17, and I get negative 12. And that is my final answer. So you're going to see there's a lot of rules with, you know, if you're multiplying, you add the exponents. If you're dividing, you subtract the exponents. And it's good to know those rules. All right, the next one is, this was actually asked by one of your wonderful classmates. Says Module 0, Homework 3, radicals. How do I know a radical? That big old square root. Okay, so anytime you see that the root symbol. And this is question number 7. Remember a square root. So like the square root of 9 equals 3. Why? Because 3 times 3 equals 9. It is just really understood that there's really a little 2 there, and that means you take things out in 2s. In fact, I tell students you could break 9 down into 3 times 3, and when you have 2 of them, you pull one out. So let's say we had the square root of 27, and I know 27 is 3 times 3 times 3. Those timetables are coming back to help you, right? I pull 2 out, becomes 1, and I have 1 left under that square root. All right, so that's kind of how these square roots work. So the same thing here. If you didn't know this, I know 10 squared is 100, right? And so I just kind of pick up the calculator and I do 11 squared. So I know 11 times 11, and I use a dot for multiplication. I don't tend to use X's because they live in Texas. Get it? That was a joke. Because when we get into algebra stuff, like up here, is that a variable? Sometimes I might put an asterisk, but a dot means multiplication, as well as even just put in parentheses, that means multiplication. So I know I can break down 121 by 11 times 11, and guess what? That's 2. And then I see, and I mean 2 of them, I see there's 3 x's, 1, 2, 3, divided by, I don't know anything I can do with 13, but I can break t squared, t times t, and all of that's over this square root. And remember what the rule is if you see 2 things, I see 2 of those, I see 2 of those, I see 2 of those, you can pull the 2 out and it becomes 1, right? Because again, this whole deal over here, I have 2 x's, pull one of those out. I have under the square root still an x left, so we'll come back to that. On the bottom here, I have, I didn't mean that line to go that long. On the bottom here, I have a t that I can pull out. And then under my big square root, I still have this x and that 13 left. Now, you will see sometimes, and this is another rule with radicals, when you're dividing a radical, you can do this as well. You can separate them into square roots. In fact, I could have done that from the beginning. I could have rewritten this as 121x cubed over the square root of 13t squared. That's a good little rule to use as well. Another thing that you ought to look at is, will 13 divide into 121? No, it won't, evenly, I should say. But those are just things that you want to look at. So enjoy your Wednesday workout. Let's get in shape and have fun with these exponents and radicals.